Hi guys, welcome to another video. Today we are continuing with Euclidean geometry and we are doing yet another theorem, and we are doing the investigation of this theorem. I'm not going to state the theorem, we're just going to go deep into what the theorem entails and look at what happens with the shapes. So starting off, we have to construct a circle. Now we want to find out what happens if I construct a circle and I form 4 points on the circle. Here are my 4 points and I've joined my 4 points. So now let's label the points. I want to label the center as O. So what I'll do is label point and then I'll label it as capital letter O. Let me use my caps lock. So here's my capital letter, and I want all the other points to be A, B, C, and D. So what I'll do, I'll say show label, and this point I should have labeled as A, but now let me label this one as label point A, and then this will be point C. Let me label it as D so that the labeling goes clockwise. Label point C. Okay, fine. So now that we've labeled our points, we have 4 segments here, and this shape is a 4-sided shape and we call it a quadrilateral. But now, because the quadrilateral has its vertices on the circumference of a circle, we call it a cyclic quadrilateral. So it is a very different quadrilateral because its vertices are on the circumference of a circle. So we must know the difference between a quadrilateral and a cyclic quadrilateral. So a cyclic quadrilateral has its own special properties that we are going to investigate. Okay, fine. So I have my cyclic quadrilateral, the quadrilateral A, B, C, D, and it is having its vertices on the circumference of circle O. So now what I want to do, I want to measure angles now. If I measure this angle C, angle C is 80.76 degrees, and then if I measure angle A is measured, and that is 99.24 degrees. If I measure the angle B now, angle B is measured, and let me just separate them here. That's 72.55, and then I want to measure angle D. That is 107.45. Okay, fine. So I want to find the relationships between these two angles. Angle BCD is BCD, and the angle is at C. So we're looking at the angle C, and over here we're looking at BAD. So it's BAD, and we're looking at the angle A, and these angles are facing each other, meaning that they are opposite to each other. So let me just mark the opposite angles. I want to mark this angle as gray, this angle is gray, and then this one I want to use red. So here's my color, red. Also mark this one as red. So fine. So the opposite angles are B and A marked as gray, and then C and A marked as gray, and B and D marked as red. So now I want to find out if I'm going to add the first angle C, add it with angle A, and what do I get? If I add these two angles, I get 180. Let's see if it's the same for the other two angles. Calculate. I'm going to add angle B plus angle D. And there we have it, 180. So now, in our investigation, we found that if the vertices of a quadrilateral sit on the circumference of a circle, then the opposite angles are going to be supplementary, because if we add them, they give us 180. So that is a theorem in geometry, that opposite angles of a cyclic quad are supplementary. And that's how you can prove that a shape is cyclic, that a quadrilateral is a cyclic quadrilateral. You can prove that its opposite angles are supplementary, and it's not for every quadrilateral, but only for cyclic quadrilaterals. So I hope you enjoyed the video. Please like, comment, and subscribe to the channel. So it's a theorem that you need to know in geometry, that opposite angles of a cyclic quad are supplementary. For the next video, we'll be proving why they are supplementary, and I hope you do continue watching the videos. I'll see you next time.